rental company with over 20,000 locations in the U.S. Customers pick up a truck and drive their belongings to their new home. The cost of renting a U-Haul depends on the number of miles driven in the truck. So is everybody familiar with the U-Haul? That's not a new idea to anyone, hopefully. So it says, the table below shows the relationship between the number of miles driven with a U-Haul and the cost of renting the U-Haul. So when we look at that, if you drive 10 miles, it's going to cost us $28.89. 15 miles, $33.34, and so on. Okay, I'm not going to read all those out. A wants to know what is the average rate of change in the cost of the rental between M equals 10 and M equals 25. So are there any trigger words in that question that make you go, oh, I should know what this is, and I do know what this is? Rate of change, that's the one I'm looking for. And what is a rate of change in your everyday Sand Mountain language? What's another? Whenever you think rate of change, what do you think about?
Is something with percents?
No. Okay. Maybe, but that's not the way my brain would go.
How much something changes from one thing to the next?
Okay. Yeah. That's true. That's still not the word I'm looking for. There's a word I want you to think of every time you see average rate of change. Every time. Nope. These are all good things. I don't want you to think that I'm saying you're all wrong. You are going to subtract. It is what did you say? How much something's changing by? And I guess it could be a percent if you go to the pitch of a roof or the grade steepness of a mountain.
Inflation.
No. Every time. Slope is just a rate of change. So you're really looking, what's the slope of the line between M equals 10 and M equals 25? You guys knew that, right? Rate of change, slope rate of change. You know now, though, right? Yeah, I mean, boom, automatic. So question, how are we going to find the slope between 10 and 25? Yeah. See, that I told you weren't wrong when you were saying find the difference, and the difference was not Caesar Cazares, right? So yeah, find the difference. So there's a couple ways you could do it. I'm just trying to see how you guys would do it automatically without me telling you how to do it. I could find how much did I change to go from 42.24 to 28.89 and subtract there. 13.43. Was it 13?
13.35.
Okay. Sorry, I don't have my calculator. And so if I'm changing by 13.35 in cost, I need to also figure out how much am I changing in miles driven. I can do that one in my head. I don't need your help. 25 and 10 is 15. And so what would be the average rate of change? What's the change in Y over the change in X? Delta Y over delta X. So 13.35 over 15.
Maybe negative 13.35.
Why? Tell me why.
28.89 does a 10, and then you're going up miles but down cost. mean, up, I don't know.
So here's what I'm saying. The way I did it, I subtracted this point from this point. So if I subtracted 42.24 from 28.89, it would be positive. If I go from here and subtract this one, I have to do the same thing here. So it would be 25 minus 10.
So that one should be negative?
They would both be positive. 25 minus 10 is positive. Right here, the bigger number minus the smaller number. So they would both be positive the way I did it. If you went in the other direction, they would both be negative, and that's still fine. But you would have a negative divided by a negative, which would still give you the positive. Are you following what I'm...
Yeah, you just went back and so confused.
But I went the same way both times.
Yeah.
So as long as you go the same way both times, you're good. And do you know why I went backwards? Well, we'll get that in a second. What do we get here on this? Is that rounded?
No, that's
Perfect?
Yeah.
So the average rate of change is 89. Let's give context. 89. What's the unit on top? It's money. So 89 cents. And what's the unit on bottom? Miles. So this would be 89 cents per mile. Okay, the reason, any questions what I've done so far? Yep.
Just kind of like, as a, so if we were dealing with money and it had more than 2 decimal places, would we round to 3 or 2?
Yeah, until I know for sure, just go to 3 every time.
I
I'm with you. I know it. I know. Surely they would be nice if it was money. But remember, I haven't seen an actual practice test, and they haven't told us that for sure. So let's just get in the habit of going to 3, because I know that we're probably in the habit of not going to 3. Even though it doesn't make sense with money, just go to 3. Because, like the gas station out here, it goes to 3 decimal places. Did you know that?
Yeah.
Do you know that? Can we see? Oh, the tree's in the way.
I would want to see that color.
At the very end of gas stations, like this one right here says 9/10 at the end, because it goes to another decimal place. Sometimes they just put a little 9 up in the corner. So there is precedence for money going to 3 decimal places. Stupid gas stations. Well, this is off the rails. Okay, this is one way to find the slope. Another way you could have found the slope, and this is the reason I went backwards, because in my head, I could use the slope formula. y2 minus y1 over x2 minus x1. So I always pick the point farther right and subtract the point to the left. That's just the way I've always done it. Do we follow what I'm telling you to do here? It's the same steps. What do? Subtract the y's, subtract the x's, and divide them. But it's just going straight to the formula. I know some people think I must plug into the formula. Okay? That's, if you need that, there it is. Or you can reason through it. Either way. Well, that's boring. So what does that make you think if you have 2 different rates of change that are the same rate of change? It's linear. Correct. That's what you need to get from that. Because the 2 different rates of change were the same, we know it's linear. So the little note that they have written over here to the side, they have said that let me get out of yellow and green. They have said that the average rate of change is constant. Another way to think of that, the slope is constant. The slope's the same. If the slope's the same everywhere, it's a line. Oh, it is number 3, isn't it? I don't know why they put that note there. All right. Am I good to go to the next slide? Better speak up, because I'm moving. Look at 2, graph the points. Then what does the graph reveal about the relationship? Well, I might have already ruined this. That's all right. 10 and 28.89. That's right on the money right there. 15 and 33.34. It's going to be a little bit above. No. Yeah. We'll go right there. Okay, 25 and 42. $40 and $55. And $50 and $64. So those are the 5 points that they gave me. Well, hot dog. I can't draw a straight line. It's close. Right? So that's where they're asking, what does the graph reveal about the relationship between the number of miles driven and the cost of the rental? The points make a line. Yeah. Don't overthink it. You guys can math. And then another note they make here is the slope is constant. That's what being linear means. There's a constant rate of change. So 3 is the rate of change increasing, decreasing, or staying constant. We've already talked about that. It's constant. No matter which 2 points I pick on this line, picking any 2 points, gives an average rate of change of 89 cents. So I just abbreviated average rate of change because I was running out of space. Right? The AROC. Yep, I've half tried that before. My handwriting's not much better, number 1. Number 2 is when you hold a pen on an iPad, it's heat censored. So when my pinky touches and drags, so I had to buy, I called it my Michael Jackson glove. I wore a glove that it only covered my pinky and the rest of my fingers were out of the glove. But it still didn't work great, so. You'll get used to it. I'm used to it. It'll be fine. I mean, you can read that right. I can read it.
Your eyes are just funny. They're just 2 dots.
Yes, people think my eyes are semicolons or colons. Part of it is because, see, some eyes are okay. But whenever you do quick movements on this program, it lags sometimes. And so even if I drug, it may only got the first and last. Nobody cares. Look, just tell them you're sorry. Hey, I'm sorry, guys. This is what I got. 4. U-Haul charges all of its customers a minimum base price regardless of how many miles they drive. What is the base price? And how do you know? Think. Think you got it? No? Okay.
$20.
Why?
Because 10 times 89 is, or
0.89 is 8.9.
So we know if you drove 10 miles at 89 cents a mile, that means that you accumulated an extra cost of $8.90 for that first point per mile. And if they charged me $28.89, of that $8.90, so we were close, it's going to be, you know how these businesses have to run. $28.89 minus $8.90. Low cost of $19.99. We can't charge you $20. That's too much. $19.99. So that's correct. That's exactly the steps we need to take to get that. Are there questions about how I came up with that?
Yeah.
Yes? So the very first point I know is after I drove 10 miles, it cost me $28.89. And I know by finding the average rate of change, it's costing me 89 cents per mile. So how much did I get charged per mile in that first 10 miles? Well, I could take the 89 cents per mile, multiply it by 10. That means I was charged $8.90 per mile for the first 10 miles, or $8.90 total for the first 10 miles. So if I took that off of the total cost, it's my cost per mile, from my total cost, that's going to give me the initial starting price. What does this point represent on the graph? If I drove how many miles? 0 miles, they're going to charge me $19.99. So this is the y-intercept. It should be, see, my line's close. It should be a little closer to 20 probably. Right, but that's what you get when you have wide margins here. It's hard to get an exact line going through there. So it says, how did we know? So let's work on our explanation. So how did we know? You really having to explain what we did.
gives a lot, I don't know, on the graph,
Say that again. Sorry, I was reading.
keeps the line
Okay.
here.
Okay. Okay. That's one way you could explain it. You could say, when I look at the graph, the problem is only giving a graph explanation is you could get a roundabout figure. You could probably, like, I probably don't know this is $19.99 from my graph, but I could know it's around 20, right, by explaining the line. The way you could get an exact answer, we could say, just kind of explain what we did. The cost of driving 10 miles subtracted from the total cost. Let's just call it the price, the total price. Left a cost of $19.99. And again, it doesn't have to be said exactly like this. Just some form of explanation. Okay, look, I'll fix that. That's a bad. I'll fix that one letter. Is there another letter that's really bad? On my list, I'm going to hopefully get a new iPad this year. Hopefully it doesn't lag as much. Who knows? So what things have we found? We found the average rate of change, which is the slope, and then we found the y-intercept. So if I know the slope and the y-intercept, and then they ask me on number 5, write an equation, C of M, for the cost of renting the U-Haul and driving it M miles. If you look back at number 3 here, it says, beside, is the rate of change of cost increasing, decreasing, or staying constant? We just said it was changing constant. Or, let's just start over. Look back at number 3 here for a second. It said, is the rate of change of the cost increasing, decreasing, or staying constant? We said the rate of change is staying constant. So this is probably a new idea, but let's talk about the rate of change of the rate of change. Okay? This is a very calculus idea. The rate of change of the rate of change. So think about, if you want to think back to where they were here on the table. If I were to find the rate of change between these 2 points, what would it be? 0.89. And if I were to find the rate of change between these 2 points, 0.89, because it's linear. And between these would be 0.89, 0.89. So 0.89 is the rate of change. So think about it. If you had to find the rate of change of the rates of change, so the slope of the slopes, it would be 0. Because if I subtract 0.89 from 0.89 divided by 1, or divided by anything, it doesn't matter. The rate of change of the rate of change is 0. So that little note they made beside 3, the rate of change of the rate of change is 0. That is a move towards thinking about derivatives, which again is a very calculus-based idea. But guess what you're in? Pre-calculus. So I take the algebra that you know and we try to push it towards, what does that look like in calculus? So rates of change of rates of change. And then another idea that they want us to talk about is tangent lines versus secant lines. So you probably talked about those kinds of lines very briefly in geometry. So let me go to a new slide. So if you look at this line, and it's it's a weird idea on a line. If you look at any secant line through the line, so if I pick a point here and a point here, if I were to connect those 2 points that are on the line, what would I get? The same line. Because it's a secant line. Well, the tangent line that would touch at any one point with that slope is the same. So the point they want you to get at is on a line, a secant line, and the tangent line are the exact same. Because the slope of the line is the same everywhere. Let me give you an idea of when it's not the same. Think about a parabola. Okay? There are several different secant lines you can draw on a parabola. Just pick any 2 points. Here and here. This would be my secant line. Touches the parabola in 2 places. Now, is the slope of that secant line the same as the slope of this secant line? Because the rates of change are not constant with a parabola. You see that? So if I took a secant line here, and then if I found a tangent line at this point, I didn't draw it exactly right, but it should only touch that parabola in one spot, that they would have different slopes because they have different rates of change. Really what they're wanting you to look at is the slope of this line, think about this blue line, is the average rate of change between this point in time and this point in time. The average change between those is the slope of the blue line. The average slope between these 2 points would be the slope of the purple line. But at any given point, like if I took this same midpoint, but I went with this as the start point for the purple line, I get a very different slope. So the idea is the closer the 2 points get together, the closer you are of getting a tangent line out of that secant line. If I pick 2 points that are really close together, it's going to essentially be, again, you don't have to know all this yet. I'm kind of going a little off the rails. That's really close to if I drew a tangent line through that 1 point, because the points are real close. Anyways, notes for today's lesson. Let's see if we covered all this or if there's anything I left off. Linear functions have a constant rate of change. Each equal interval of the domain produces an equal change in the outputs. I left that part out. You need to put a big time star beside that. That came up a bunch in a bunch of our practice questions. The statement, each equal interval of the domain produces an equal change in the outputs. Which means if my x's were changing by 5, and the y's changed by, well, in this case, let's just do, when the x is changed by 1, the y is always changed by 0.89. Right? Every time. So an equal change in the x produced an equal change in the y. That should probably. So we kind of know that, but you're going to have to use that as an explanation in a few questions. So make sure you remember that. When the rate of change is constant, that means the rate of change is 0. Ooh, they threw a word concavity in there. Lines have no concavity. You don't know what concavity is? It's okay. You don't have to know yet. We'll talk more about that later, but just kind of get an idea of, oh, there's a word I'm going to have to know. And then 3, the slope of a line represents the constant rate of change. If the slope is greater than 0, that means the quantity is increasing. If the slope is less than 0, the quantity is decreasing. So again, some very simple ideas that you're familiar with. Just writing them down. Once you get finished with the learning targets, like I said, I don't care how much of those you write, don't write. I definitely want you to write this one. You need that sentence. That's going to be used over and over again. I'm going to give you the rest of the class to work on the check your understanding. If we get finished, we can go over it before class is over. The difference between a tangent line and a secant line. If you don't, that's okay. I wouldn't have remembered it from geometry. You do? What's the difference?
The tangent line only touches 1 point, while a secant line can touch multiple.
2. So secant will be 2. So when you first learned about it, you talked about circles, and you had like a chord of a circle. That would be considered a secant line because it touches the circle in 2 places. But a tangent line would be a line that only touches the circle like on an outside edge, like this. This is a tangent line. So again, that's a very geometry idea. Is everybody good with this, this vocabulary? Tangent versus secant. So again, if I go back and look at my graph, okay, now I am. What do we get on 5 as our equation? 0.89 plus 19.99. That's it. Okay, questions there?